Let us understand cyclic code through this example. With this example, you will be understanding how to select a generator polynomial, then how to generate a non-systematic cyclic code, and after that we are going to see its properties. That means there are two properties of cyclic code: linearity and cyclic shift. So that we are going to see after solving this problem, so that you will better understand those properties. So here we have to design a 4, 2 cyclic code. So 4 is n and 2 is k. That k means number of message bits, right? Number of message bits, and 4 is number of code word bits. So the first step is you have to obtain the generator polynomial. We have seen in the previous video that we have to obtain the generator polynomial, which has two features. That generator polynomial has degree n minus k. What is degree? Degree is highest power of the polynomial. So its degree is n minus k, and it is a factor of x raised to n minus 1 or x raised to n plus 1, because in mod 2 operations minus 1 is equal to 1 plus 1. That's why you can obtain factors of x raised to n minus 1 or x raised to n plus 1. So let us do this task first. So n equal to 4 and k equal to 2. So we have to factorize x raised to 4 plus 1, x raised to n plus 1. So x raised to 4 plus 1. So the first step in the factorization is same for all the factorizations which are like x raised to n plus 1. So the first step is x raised to 4 plus 1 is you have to write first x plus 1, then next factor is 4 minus 1 is 3. So x cube plus x square plus x plus 1. So this was also explained in one of the video, how to factorize x raised to n plus 1. So if it is x raised to 5 plus 1, then it is x plus 1, x raised to 4 plus x cube plus x square plus x plus 1. So this is first step. So after that x plus 1. Now in this we are doing in Galois field 2. So by trial and error we can say that if you put 1 here, this is this part is we are not going to consider now x plus 1, because it is already factorized, almost factorized. So x cube plus x square plus x plus 1, we have to once again factorize it. So if you put 1 as a root to this equation, so 1 plus 1 plus 1 plus 1, 1 plus 1 is equal to 0 in mod 2 operation, then 1 plus 1 is equal to 0. So this 1 is the root of this polynomial. So one factor of this polynomial is x plus 1. If one factor is x plus 1, then another factor you can find by the division method. For example, this is x cube plus x square plus x plus 1. In this one factor we have found it as 1. So divide it with x plus 1. So one factor is x plus 1. So first quotient is 2, because you have to make it, what we were doing here, we are subtracting 3 minus 1. So 3 minus 1 x2. So this was also explained in one of the video. 3 minus 1 is x2. So multiply x2 x square with x plus 1. So that is x cube plus x square. So in mod 2 similar will get cancelled out. Remaining is x plus 1. Then division is 1, because this 1 you have to multiply with x plus 1, that is x plus 1. So this gets cancelled out. So remainder is 0. So another factor is x square plus 1. And if you multiply x square plus 1 into x plus 1, you will get x cube plus x square plus x plus 1. So next factor is x square plus 1. Now the condition for the generator polynomial is its degree, means highest power. You got 3 polynomials, that is x plus 1, x plus 1, x square plus 1, actually two polynomials, that is x plus 1 and x square plus 1. So in this, the degree is highest power of the polynomial. Its degree is 1 and its degree is 2. So what generator polynomial degree you want? You want the generator polynomial degree as n minus k, that is 4 minus 2. So that is equal to 2. So the polynomial which is showing that degree is x square plus 1. So we have selected generator polynomial as x square plus 1. So gx is x square plus 1. So the first step is, once again we will revise it. First step is you have to see what is n. N is 4. Then you have to factorize x raised to 4 plus 1. First step is, this is common for any x raised to n plus 1. Then after that it is almost factorized. So you have to factorize this one, x cube plus x square plus x plus 1. First factor you can obtain by trial and error. So we have tried for 1. So we got that if you put 1 here and you get 0 because it is Galois field 2 operation. So another factor we obtain by the division method, that is x square plus 1. So this is first step, we got the generator polynomial. Now we have to obtain now the code word polynomial. For that you have to see how many message bits are there, k equal to 2. So if there are 2 message bits, then combinations are 4. So 0 0 0 1 1 0 1 1. So by the way you are going to get only 4 code words, because how many message bits are there now, those code words you will get, or in your code set you have those many code words. So message m1 is equal to 0 0, m2 is equal to 0 1, m3 is equal to 1 0, and m4 is equal to 1 1. Now we will obtain the polynomial representation for this. So for 0 we will write it as 0, for 1 1, and this coefficient 1 is for x. So x plus 0, this is x plus 1. How to form the polynomial from the binary, that we have seen in one of the video. Then we have to obtain the code words. So for obtaining the code words, you have to multiply these message polynomials with the generator polynomial. So first code word c1x is, you have to multiply 0, this message polynomial, with the generator polynomial x square plus 1, you get 0. Then second 1 with x square plus 1, that is generator polynomial, that is x square plus 1. Third polynomial, message polynomial is x. So x into generator polynomial x square plus 1, that is x cube plus x. Fourth polynomial message polynomial is x plus 1, generator is x square plus 1, that you will get it as x cube plus x square plus x plus 1 if you multiply these two. So x into x square plus 1 is x cube plus x. So x plus 1 into x square plus 1 is x cube plus x square plus x plus 1. So you got the code word polynomials. So code words polynomials are 0, then x square plus 1, x cube plus x, and x cube plus x square plus x plus 1. Now you have to obtain the binary representation. Now the message n is equal to, so these we have copied there. So n is equal to 4. N is equal to 4, that means number of bits in the code words are 4. So for 0 you have to write 4 times 0. For x square plus 1, so 1, then x term is not there, so 0. Then x square is there, yes, that's why 1. X cube is not there, so 0. Then x cube plus x, so first you have to start with 0 because there is no 1 and 0. Then x term is there, so 1. X square is not there, so 0. And x cube is there, so 1. Here all the terms are there. This is 1. Then x, for x coefficient is 1. X square coefficient is 1. X cube coefficient is 1. This is explained in the video how to form the binary representation from the polynomial. So this x cube is for this MSB bit, and this one is for the LSB bit, and these are, we are writing the coefficients of the x cube x square terms. Okay, so code is equal to this set, which includes this and this. So this is the code which includes these 4 code words. This you can see in many of the books. They say it as code set or code. So this code includes these code words. Now let us see what are the properties of cyclic codes. So first is a linearity property. That means addition of 2 code words between these 4 will give another code word. That means if you add any 2 code words, you will get a code word which is there in this, which is amongst these 4. So for example, if you add 0 with every 0 with all these 3, you will get the same code word. So if you have added 4 times 1 with 0 1 0 1, then addition is 1 plus 1 is 0, 1 plus 0 is 1, 1 plus 1 is 0, 1 plus 0 is 1. This is XOR operation or mod 2 or Galois field 2 operation. So this is nothing but a code word 3. So addition of this and this is this one. Now addition of these two, addition of this is 1 1 1 1. Addition of these two is this one. Addition of this and this and this, 1 0 1 0 is 1, 1 plus 1 0, 1, 1 plus 1 0 is this one. So addition of any two code words is again a code word. That means if you add any 2 code words, you will get a code word from amongst these 4. That is linearity property. Then second property is cyclic property. That means cyclic shift of any code word is again a code word. So if let us take a code word 1010. So that code word is this one, 1010. Now if you do the cyclic shift of this code word 1010, if you do one cyclic shift, that means you have to take 0 here and write all 101 as it is. So 0 here and 101 as it is. This 101. So you get a C2. That means cyclic shift of C3, you are getting C2. Again, if you shift do the second shift to this C2, then you will get 1 write down 1 here and 0 1 0 as it is. You will get C3. Again, if you do the cyclic shift to this, then you will get C2. That means cyclic shift of any code word is again a code word. Let us take the another code word 010. 010 is C2. If you do one cyclic shift, that means take 1 here and copy 010 as it is. 010, you will get C3. Then take 0 and 101, you will get C2. That means cyclic shift is again you are getting this code word from the code set. If you shift 4 times 1, that is another one code word, you will get the same code word. If you shift 4 times 0, you will get the 0 only. So not needed to shift these 2 code words, that is 4 times 0 and 4 times 1. So this is cyclic property. That means cyclic shift of a code word is again a code word, and addition of 2 code words is again in the code set, that code. Many times I also got many times when I was teaching, I also get confused with the statement that addition of 2 code words is again a code word. I was not getting what that means. That means you are going to get the code is nothing but a set of code words, and if you do the addition of 2 code words, you will get the addition from that set only. That is the meaning of that sentence. And so a cyclic shift of any code word is again a code word. That means if you do the cyclic shift of a code word, you will get a code from the set of that code, which the set contains code words, and set is called code, and code contains set of code words. So a little bit confusing, but simple is code. This is code, which includes a set, and in that set there are code words. So that's it for this video. I hope you got the meaning, or you got you understood how to obtain the non-systematic cyclic code, because we obtain here the non-systematic cyclic code, which is obtained by multiplying message polynomial with the generator polynomial. So you understood what we can say, what is that, how to obtain the generator polynomial, and you also understood the what are the properties of the cyclic codes through the example. So thank you for this video. Thank you.